Okay. So our instructions say. Complete the square, rewrite the standard form of the graph, label the vertex focus, and directrix. Directrix. That's the word I'm trying to say. And there it is. So, what should we do?
We should put it in the form that we need to put it into. We should complete the
How?
Subtract x and we should complete this square.
Subtract x, 12x, and negative 20. Move them over there. Sounds great.
Except where we add
Y squared plus 4y equals negative 12x minus 20.
Complete the square.
Okay, how?
4 divided by 2 squared is 4.
4 divided by 2 squared is 4. True enough.
And then we factor.
But we already
This is what I did.
Except you did it wrong. You just factored straight
Plus 4 over there, right?
Complete the square.
Yeah, you're right. I just like to more to exist.
Okay. So y plus 2 quantity squared equals negative 12x minus 16. Now what should we do?
Now we should
Factor out
I already did that. Now we want to
Divide both. Divide
We are
12x.
minus 16 by negative 12. I think we did something.
If you divide that by negative 12, you got to divide the other side by negative 12 as well.
Well, like factor it out.
Factor 2 out of the right
Actually,
side.
go factor
No,
4 on
no.
the right side.
Well, we have 12 out of that because
You
we have
can't factor
something
12.
wrong. We have something wrong.
Okay, what do we have wrong?
It's not negative 20, it's positive 20.
Oh yeah, it is. You're right.
Yeah, and then it's 24.
And then it's 24,
And
and
then
then
we
the 12
factor
factors
12.
and everything works.
I knew we did something wrong. Because I said this at the
That's
start.
Because I got this problem right.
Okay, now what?
Now we factor out a negative 12.
Sure.
And so we get y plus 2 squared equals negative 12 x plus 2. That's when I messed up. I did a negative 22 somehow. So what? His 4 became a 2 and his 20 became
4 became 2 and 2. Okay. And then what?
Then we have to find the vertex. Then we find the vertex, which is 3y. And
What did you say it was?
I was looking at
Because it's definitely, there ain't no 3's there. Ain't no sunshine when she's gone.
No.
2 negative 2, not 3 1.
Okay. Does it say to label the direction of opening? Probably not because we're graphing, right?
It does, but it opens left, so it doesn't really
Yeah.
matter. And
So
we
the
have
D-O-O left. Great. Everything else we're going to shove on here. Okay. So,
Let's get like 2 points.
what are you saying? Oh, let's get like 2 points. I see.
I was saying something that actually made sense.
Let's get like
Yeah, but I didn't hear it, so whatever. To the right 2 and up 2. Okay, I've got a point. Good for me.
What was that noise?
why do we have right 2 and up 2? Shouldn't it be right 2?
Oh, yeah, you're right. Down 2. I keep messing this problem up. Don't know what's going on with this problem. It's going crazy.
I think it's just today. Today everyone's crazy.
Today everyone's crazy.
Malcolm actually I was crazy.
Malcolm's actually like
Okay, so what should we plug in for y? Negative 2? I love that idea. Let's do that. That sounds like a great idea.
y equals negative 2 and then x equals 2.
Negative 2 right there.
That's not how that works. Never mind.
Right, so we've got 0 over here, right? Equals negative 12 times x minus 2.
We should divide by 12.
Divide by negative 12, and we get 0 equals x minus 2. We add 2, and we get a 2.
Yay!
And it's symmetric this way. Well, it's actually symmetric this way.
We already have
Isn't that the vertex?
That's the vertex.
Oh, yeah. It is the vertex. Good job. We solved for the vertex again.
That
I don't know what it is about today. Because I was thinking about x negative 2 is where that's where I got that's why it showed up
Why
there.
don't we put x is negative 2?
How about 0
How
and
about we
Wait, that would help.
How about we put a 0 in there? That sounds great.
and we get 4 equals
Okay, so we've got 4 equals negative 12 x minus 2. Divide by negative 12, and we get negative a third, right? Then we add 2, and we get 1 and 2/3.
No, wait, yes. I was about to say 5/3 or the correct answer that I realized.
Didn't you
That's the
realize
same
you were
thing.
stupid?
2, what did I say? 1 and 1/3, 2/3.
1 and 2/3.
Okay, there we go. So y2 and 1 and 2/3, so about right there, and then the symmetric point over here, which is about right here. Clearly I haven't drawn something, oh no, it's not right there. No. It's not remotely right there. It's, how about we keep going a little bit further, because that would be 3 and 2/3 away from that point, right?
Yes.
1, 2, 3 and 2/3. Now we're cooking with crystal meth. Oh wait, no, not that. Stop, no. That's a bad idea. We're not gonna Walter White ourselves into stupidity. That's a bad idea.
That's going to get canceled for this. On YouTube. Did you say
You can't get canceled if you were never, whatever the opposite of canceled is. If you were never famous. Also, you can't get canceled if you choose not to be canceled. And y'all know that I would never advocate doing crystal meth. That's a stupid idea. Like, if I was going to advocate doing some sort of illegal drug, it would definitely not be that one. I wouldn't advocate any, but that would be like way low on the list. I think it probably like crack cocaine would be like one of the only things that's lower and a worse suggestion. Okay. There it is. That was beautiful. So what other homework questions do we have?
He said 5.
He said 5. He also
I
said
say
7.
7. I say 7.
Okay, we'll do at least part of 5 because there's probably something in there that you just like tweaked weird, I bet. I mean, of course, you also kind of said you missed them all, and you also kind of said that you knew why you missed them all, so why do you even have a question? I don't understand. But let's look at least part of 5.
This one I actually don't know why I missed it.
Okay.
All the other ones I know why because I was just being retarded.
Okay. I see. So, cut same instructions with x squared minus 6x minus 8y plus 17 equals 0.
We should add 8y and 17.
We should add 8y.
Sounds good. Add 8y and subtract 7. Well, I'm going to do that first so I don't make a sign mistake again. So 8y minus 17 equals x squared minus 6x. Complete the square. Negative 6 divided by 2 squared, negative 3 squared is 9.
9 plus 9.
We add 9. Add 9.
We factor things.
This factors into x minus 3 quantities squared equals 8y minus 8. Factor an 8 out. Y minus 1. X minus 3 squared. My 2's are just like on vacation. Okay. Sounds good. Did you find your error?
The rest of it.
Did you find your error?
I just kind of was dumb.
His whole
Okay.
problem was the error.
Yeah, that's a fair statement.
The face was the error.
All right. Which one did you say, Malcolm?
He said 7.
I did say 7.
Okay.
And I said 14.
Wait, write the
And
equation.
26.
What? I'm sorry.
Given information.
I wasn't given the same problems as you then.
What?
He said he wants to do 14 and 26.
Oh. Well, that might show up on a later one, but
Oh, no. Uh-oh.
Uh-oh.
Uh-oh. I like 8. 8 was good.
8 was a beautiful number.
Well, I mean, these
I
problems
got
did take a second.
two examples of everything.
That's what I always.
Which is
That's
why
what
I
you
shot
used to
more
always
tiles.
do.
And they were both very different, so like they were the opposite sides of each one.
Are those your new boots?
These are
They're like
been my
semi-new.
I know. I just remember you saying that a lot.
okay, we've got to use that stuff to write an equation and then graph the thing. We've got a focus, we've got a direction of opening, and a random point. So,
So
what should we do?
Focus, so we have the.
So before I did any of the things y'all were saying, I would ground myself in reality somewhere.
And write down the.
I would probably very poorly and chicken scratchy. I would go like, okay, here's this, and then 1, -1. This is the focus. Direction of opening is down, which means it's going to be something like this, right? I would do that. It's like ugly, but I would be like, okay, this is where I am. This is what I'm looking for. That way, if I get an answer later that doesn't make a dadgum bit of sense, I'm actually going to catch it because I thought through what I'm looking for, right? So I would, even if it's as ugly as that, I would do this first real quick because it takes half a second and it'll lead to less errors later. Now that we are grounded, now what?
Since we know it opens down, we can be like.
square with a negative p.
What?
Let's write down x.
Let's write down what either A, we know either H or K. Which one?
Equal to 1.
H is equal to 1. True enough.
And then k plus p equals -1.
K plus P equals -1.
K minus p because it's down.
That's directrix.
Nope. That's.
Focus is always
Oh,
adding.
No, because it'll be a negative p.
Yeah,
So
P will be negative.
And then we can just like put a random point in the parent function.
Okay, so what is the parent function?
x
X
plus
times H squared equal for quantity squared.
equals
4p y
times
minus k. You're selling worse.
Okay.
You're talking over me.
You
Face
your
is talking
calculator
over me.
wrong, is the problem.
You know what else is kind of awesome about, this is not anti-gravity, but going through the process of building this stuff with AI and my own work and whatever else, it also has improved the way I am teaching this unit.
Yay.
Like every year I've gotten better at teaching like all the stuff in pre-cal. In the first year in pre-cal, we didn't really do pre-cal. I had 2 students and one of them was like great and the other one like never did anything. And that was a really crap class.
That sounds like a very average class, right?
It was, yeah, but extrapolated out. And when it's like, well, anyway, that wasn't a great class. But then the next class, there was a bunch of people that were really low, and then one person that was pretty high, and so we went very slow. And then last year was a better, and then now here's you.
Yay.
We're the best.
We're special.
Yay.
Especially Malcolm.
Okay.
Malcolm got a nice.
All right, what now?
And
What?
he's very special though.
I'm very special.
Alright, now we're gonna like throw in some numbers for x and y.
Yep. Throw in some numbers for X and Y. Throw in an H. Yep.
And what else do we want to throw in?
But we have K plus P equals -1, so we can just make this
We do.
a little bitty system after
So-
we like simplify something.
We don't even have to simplify it yet. We could just make plus
6
x
squared is 36 equals 4p 1 minus -1 minus k. Ah, yes. That works.
We could do that. We don't have to do that. I mean, we could, but you know, whatever.
Divide by
Yeah,
4.
that's fine.
We divide by 4.
We could divide by 4. That's a good catch because 36 is divisible by 4. That's true. That's a good, that does make us some easier numbers. That's a great catch.
24, 28, 32, 36.
Wow, I hate that. Stop.
Yeah.
Okay. What now?
We can use that and the k plus p equals -1.
And so we
Use that along with k plus p equals -1. Sounds great.
Use our system now.
True enough.
Now I'm going to put this into a matrix and use reducible echelon operations.
Why?
I don't actually. I just wanted to say that.
How would you use
I was really tempted to still do substitution, but like substitute that one in over here. I think it might honestly be easier, but that's fine. Okay, which one of these do we want to solve for?
Okay.
Sounds great.
Why don't we do P?
Well, too late. They already suggested K. -1 minus P. So we can take that and put it in over here. Also, we only have one place to substitute, so, you know, that could be nice. 9 equals -P minus P times -1 minus P. Okay.
P minus P is -2P. And then.
Stop. You broke it. You did it wrong.
I did?
P times P ain't 2P.
It's P squared.
It is P squared,
But it's
true enough.
minus.
What is,
Oh,
okay.
Oh yeah, I wasn't using my PIMDOS. I should do that.
9 equals negative backwards 9 plus P and plus P. Yes, you should use PIMDOS. That is a good idea.
And then we can like kill 2P's.
We could kill 2 P's in one pod.
2P's.
9 equals backwards 9 squared.
Square root of backwards
Oh my gosh.
9 is square root of 9.
Or
So
plus
P
or minus
equals
square
3.
Plus or it could be negative.
And then I want to substitute.
Okay, so we got to figure out which one it is.
It's negative.
It is negative because we got to go back up that way.
And also because like the problem.
Because it goes downward.
Never mind.
Yeah, we got to go, down, yes. I said that backwards, but yes. Going from the focus to the, going from the vertex to the focus is down. So the negative one. So it's not this one. So P equals -3.
And then K not minus 3 equals -1 plus 3 plus 3. K.
You said that horrifically, but yeah, K minus 1 minus -3. Ka-chink, ka-chink. K is 2. Is that what you were trying to go for, right?
Sure.
Sure, man.
Sure.
Now we got all the information. So we can just start putting it in here. So we've got the quantity x minus 1, quantity squared, equals negative, what am I saying, 12. Times the quantity y minus 2.
Oh, it was
There it is. And then we graph the thing,
Yeah,
right?
maybe just killed it.
And it's gonna be down.
Did you figure out whatever you did wrong? Whoever asked for this?
I don't know what I did wrong.
I did 7
probably
plus
just made
1
some
instead of
mistake.
7
I didn't
minus
come-
1.
I didn't
Okay.
come to a different method, but I got it right, and then it's right, and that makes sense. I don't know what I did wrong. I don't know what I did right.
Okay.
Weird, just tweaked it. So I was.
He's going crazy, brov. Crazy.
This is
He's
not
not
new
going
information.
crazy. He's our true level.
What do I need in order to do this way?
A better calculator.
I need to export. Yeah, I'm gonna give a shot not using the book, using other tools. See what happens. But I gotta say this is a PDF, so it'll open on my tablet. Well, it'll open on my tablet. It'll just be ugly because it doesn't have the local files.
Because you're doing this different homework deal, does this mean like the next year's you're not gonna do books or?
Oh,
'cause-
That is the eventual plan. I don't know if it'll be next year, but that is, and the eventual plan is to make my own book and workbook and all the things. That is the direction I'm headed at some point.
He's having a book?
I've had the plan to make my own curriculum for years. That's been a thing that's going to be happening for a long time.
He is the book.
no,
Hello,
he-
Sean the book.
Sean's not a book.
Sean's a book now.
Sean the book.
Oh, so stupid.
This this and
Long shot.
You got one of
Just use the other
those.
side
I
of
want
the
this one as well.
It gives more power. I'm getting third party.
It's fine.
That's what happens when you're in the middle. And when you're a bush camper.
All right. So we've learned about parabolas.
Ooh,
and their conic definition.
Now we got
But we can cut conics in more ways than that.
Hyperbole.
We can, but we're not talking about hyperbolas yet. Dang it.
I'm so sad. Ellipses and a circle.
Dang it. What is the llama's name in Napoleon Dynamite? Why is it not coming to me? You've not seen Napoleon Dynamite? What is wrong? That seems like the movie that I could see like your mom loving that movie. I can't believe you've never seen that.
My dad hates that movie.
Oh, that's crazy. I don't know anything about your dad. Never met your dad. So, but I can tell that I hate him. No, I'm just kidding. Totally kidding. That's crazy.
I want to see it. I want to see it.
Napoleon Dynamite is literally a homeschooler who has never been homeschooled.
Okay. It's literally a homeschooler. It's never been homeschooled. Okay, so we're going to talk in this lesson about
Napoleon Dynamite could be Malcolm.
ellipses and their specialized cousin. Guys, shut it, please. Their specialized cousin, circles. I didn't say their special ed cousin. I said their specialized cousin. Those are two different words.
We're so funny.
Looking. Okay. Now, what is an ellipse?
An oval.
You know what would be easy? Except I can't really do that.
It's the special ed cousin of a circle.
No, circles are special ed cousin.
Because I can't do that, I think I am going to use the book. It's going to be easier to do this today. Easier to see what I'm going to see. Easier to think about what I'm going to think because I don't have the things on one thing. What I have right now built is not optimized for in class. It's optimized for making a video. But since I'm in class, I'm going to do it this old-fashioned way.
Going back to videos?
Brother, do you listen to the things that I'm saying? I don't know. It depends on whether I catch up to us or not.
We all know that I don't listen.
Okay. Like I was saying, ellipses. What is an ellipse?
An oval.
It's a math word for an oval. That's true. What is an oval?
It's
An elongated circle. Yes, it's
Elongated circle. Now, we have said things like what I'm about to say before in math. We have said things such as every single square is a rectangle, but not every rectangle is a circle. We can make the same claim about ellipses and circles. Every circle is an ellipse, but not every ellipse is a circle. No, you put the words in the wrong place, and it made it wrong. Okay, so when we have an ellipse, he looks kind of sort of like this, right? Or he could look kind of sort of like this, right? Now, if I was in wood shop and I wanted to make an oval, if I wanted to make me an oval, I could build one and I wouldn't even have to use a computer and grab the thing and stamp it on and make a template. All I would have to do is I would have to take a nail or a screw or something and put it right here, and then tie me a loop of string, and then put my pin in there, and it would follow in a perfect ellipse. Same thing over here. You can build an ellipse that way quite easily. And if you know the math that you're going to learn to build the ellipse, you can build it exactly how you want it. Of course, if you're doing this like IRL and you're making an oval, you're probably making something stupid like a mirror or something, and so you wouldn't do the math. You'd just be like, it's probably this. Oh yeah, that looks great. Let's go.
That's exactly what I'm thinking.
It'd be okay. I want it to be about this size. But if you have this information, you can get enough stuff. So these little dots have names because of course they do. We can't talk about things if they don't have names. These
those are the ellipse dots.
are the ellipse dots. These guys. Yes, but that's not how that word works. The foci, which is, you guessed it, the plural of focus. Focuses, the foci. Okay? So there are, in a parabola, there are, what am I saying? In a parabola there is one focus, right? And it defines, along with the directrix, the parabola. The two foci define the ellipse the same sort of way. If we have, and this is like our string, that are, I don't know why I put a 90-degree angle. It's definitely not always 90-degree angles. When it's over here, they're like overlapping each other. This distance to the point out here, we can call it P1 and P2. I think my new note stuff calls it D for distance to stay consistent. But I think our book calls it P, so whatever.
P for pistons.
P for point length or something, I don't know. Oh no, just kidding. Our book calls it D. I was right. Distance 1, distance 2.
No, it's not. No. You can be funny sometimes, but you need to learn when those things.
Distance 1 and distance 2 always, no matter where we are on the circle, always add up to the same number, right?
Ooh, I like that fun.
They always do. Well, and that's like how I was describing it with the string. So distance 1 and distance 2 plus the distance between the focuses would be the string, right?
Yeah.
And then the string just tracks around, and it's always the same, and it makes a pretty oval, right? Okay, so there are a few more vocabulary words related to an oval. So let me draw another oval. I need to build me a whiteboard oval builder. That would be fun and probably pretty easy. Okay, so we've got the foci. We also have going across this way.
Is it a diameter? But it's not,
No, the major axis.
I remember this. Oh, like the longer.
Yeah, the longer axis. And if it was a vertical oval, the major axis would be this guy.
And
Right.
if you top to bottom, it's a minor axis, if I guess.
True enough.
Major and minor.
You don't even have to guess. We learned this last year in Algebra 2.
I don't remember that. But
No.
maybe I subconsciously remember that, but or I could just be like major, minor.
Or he could just like think. Don't think.
You act like that's a regular thinker.
This is the minor axis.
Yeah, it happens about 2 times a week in math.
Right?
Whatever you want to make fun.
Now, the major and minor axis, they cross the circle. These really should go outside because the axes are
So
lines.
the minor axis is this like shortest length of the circle.
Correct. That's not a circle, but good try though.
Longest length of the ellipse.
True enough.
Wait, so is there an intersection in the center of the foci? The distance between the foci?
It's right.
Yeah,
between-
it's the center. It's the yes. So right in between them is the center, and yes. So the answer. So this is the center, and that's its name.
Oh really?
Yeah, the center is the center. We've got the foci out here, there and there. The distance between this and this is the same as the distance between this and this. Also, the distance between this and this is the same, and this and this is the same. This and this is the same. Right?
That's pretty.
It's equidistant from like all the stuff. Right? Now we have a little bit more, just a wee bit more vocabulary, but they make pretty simple sense. Pretty simple sense. This guy and this guy are the vertices. This is a vertex.
Oh really?
Ooh, we have vertexes.
Vertices, man. Vertexes.
Okay? Now, but what about these?
They're the minor vertices.
That's a good guess, and it makes total sense, but no, these are the covertices, which I think is hyphenated. Let me see. Is that hyphenated? Am I right? I am right.
I never hyphenate anything. So.
Well, you should, when it's supposed to be.
Yeah, the covertexes.
This is the covertex, and this is the covertex.
Wow. Unless it's bad.
Okay? So we got our vocab. Our vocab all good to go.
Yeah.
Yeah, wow. Okay, easy peasy. So now we got our vocab. let's get some formulas to find the things.
Yeah.
Now, if you keep in mind what I belabored on Tuesday, then these formulas are not necessarily going to be that hard to remember. Okay? Because if you try to remember which one was the x and the h, whatever, h goes with x, y goes with k, whether we're talking about an oval that's this way or this way.
Or a thing that's
Or a
this way.
parabola that's this way.
Yeah, exactly. Whatever we're doing, h goes with x, and h goes with x, and k goes with y. We're going to add a's and b's to this with what they go with.
I like A's and B's.
Okay, so the standard form of a horizontal ellipse and the standard form of a vertical ellipse. What am I saying? Ellipse is what I'm trying to say. Standard form of this one is x minus h. H goes with x, easy peasy, squared
These remind me of something.
over
Oh, never mind. A squared.
a squared
Plus y minus
We have a
k squared over b squared. Yeah.
plus y minus k quantity squared over b squared equals 1.
Oh, it's not 0, it's what?
It is 1. Now, when we...
Where was that?
Yeah, you can graph it on your graphing calculator.
They had the equation for it.
Oh, yeah, it probably does have that displayed.
They're gonna cheat on the test.
What?
They're gonna cheat on the test.
That's
And I don't get
crazy.
to. Oh no.
Now,
Why parabola?
on this one, I want you to notice what switches that I'm gonna, and we're gonna see if you can figure out what I'm gonna tell you to keep things connected. H and X go together, Y and K to go together. Now the equation for the vertical one looks like this. X minus H, quantity squared, over B squared,
Not so.
plus X minus K, quantity squared, over A squared equals 1. So A goes with which axis?
Horizontal.
It's not with horizontal over there.
It goes
Oh.
with
No,
the
major.
What did I do?
major.
It goes with the major axis. A goes with the major axis. So it will also, because this is obviously true, on the major axis, like if you're just looking at an equation, the major axis will be longer. So A, wherever it is, will be bigger. And I'm stressing this. I know this seems stupid and obvious, but I'm stressing this because when it's numbers instead of letters, sometimes people get it twisted in their brain. What is happening? But if you just remember, bigger number, go with bigger axis. Easy. Okay? No big dealy go. Okay, so to find all the things.
So you know if it's vertical or horizontal due to if the bigger number's on the left or right. That's really
No.
what you're saying
No. So don't think about it that way. Think about whether it goes with X or Y,
then. Okay.
not left or right. Because what'll happen is though it'll be written backwards, and then you're up a creek because you were thinking left, but
It was right.
So A is always bigger than B? Is wait, or am I misunderstanding?
let's get to some examples and we'll put some meat on that.
Examples?
Okay. So to find the center, how do you think we find the center? And I'll give you a hint. It's the same whether it's up and down or left and right.
Where the two intersect.
A, B.
Thanks, genius. Yes, it is where the two intersect, where the two axes intersect. How do I find it from the algebraic equation?
A is B.
Not A and B.
Is it
Where
oh,
Y
H
is
and K.
intersecting.
H and K.
A,
I was right. Let's go.
And it's the same for both. All right, to find the foci,
I just wrote foci as F-O-K-I.
That sounds great.
I question my sanity. I'm guessing A and B.
you're guessing A and B? Okay, so here's the deal. You're right and wrong all at the same time.
A, H, B, K? Or H, A?
Which one's going to stay the same on this one?
H? What do you, no, K.
H or K? K is going to stay the same on this one. They're going to go that one. Okay, so for the foci on this one, K is going to stay the same. True enough. It's the one that goes with the B axis, right?
Oh.
But to find the other part, the X part of the foci, we're going to introduce something that is hitherto invisible.
Uh-oh. Oh, no.
And we're going to do H plus or minus, and it's plus or minus because it's 2. C.
Not C.
Not
see
C. I can't see C. So before we define C, which we'll do in a second, what would the foci be for this one?
HK plus or minus C.
H, K plus or minus C. True enough. True enough, easy peasy. Now, the formula for C is going to look kind of sort of vaguely-ish familiar.
I like vaguely-ish familiar.
Ish. And there's a reason why it looks vaguely-ish familiar, but I'm just going to write it. To find C, why did they... Sometimes I have beef with the book, but it's fine. That is not what I said. If I said I went out and had beef with my wife, then I ate the beef. My wife was not now beef. That's not how the English is. See, you find C with this.
But why is that like that? Because if
That
you
looks-
square root A and B, but they're both squared, then is it not just like... but
That's not times, bro. That's not times. That's minus. Okay, so that's how you find C. Okay, let's keep going. So, to find the vertices.
That's literally the Pythagorean theorem.
Putting math, I retire.
It's not literally the Pythagorean theorem, but it's literally almost the Pythagorean theorem.
Almost the Pythagorean theorem. It's a minus.
To find the vertices
Coincidence?
on this, children, which one changes on this one?
The up and down in K. No, I take them back. That's the one that stays the same.
K is the one that stays the same.
H is the one. I have a feeling.
Now, what do you think we're going to have to do to H?
Plus 2C?
That's a great idea, but nah, see that we don't need C no more.
Now we do A and B's. No, just just the B's. I think we A's.
The long axis.
All days.
A's. Plus or minus A. Now you notice that it's A, not A squared. So in order to figure out what A is, you're going to have to square root whatever this bottom dude is. Oh no.
Is it K plus or minus B? No, then it would be
H, comma, A plus or minus K.
Yeah, that's not the way I would have said that, but sure.
H plus or minus.
K plus or minus A.
A always goes with the major axis.
Okay. And now we get to the co-vertexes.
This kind of, at this point in the thing, this goes back to what I was saying, is A always going to be longer?
Yes.
Answering your question, yes. So for the co-vertices,
There's too many things here.
Just 5, 4 maybe.
which one stays the same on this side?
The H.
H stays the same because we're going the short way. And how do we get the other part?
B.
K plus or minus B.
The way you abbreviate co-vertices is covert.
Yes. So, what does that have to do?
What am I writing?
Covert?
What am I doing, Linda?
What did Linda do?
Come on, how did
H plus or minus B and K, right? How do you find the directrix?
Oh, I forgot we had directrix in this.
Wait, do we?
No, we don't. There's no, a directrix wouldn't make any sense with an ellipse. there ain't no
It
ellipse.
would be like a bigger ellipse.
We're not gonna find
Yeah,
we're not gonna find a line again until we get to hyperbolas.
The directrix would just be big ellipse.
What?
Would the directrix not just be like
The directrix, the version of the directrix in this is the two foci.
But the directrix is like also like just a bigger ellipse.
And it's how you build it. You need two things in two dimensions. In a parabola, excuse me, ellipse, we have the two foci. But in a parabola, we need something else to get there. All right. So this is all our information that we have to do what we need to do. Right? Pretty easy peasy. And it's easy to remember if you don't like don't even really stress about the letters. Just which ones are bigger, which ones go with X, and which ones with Y. Right? That's really the way to memorize it. Because if you try to just like memorize all of this, just as all of this, it's going to be confusing and terrible. I think I'm just going to give you the homework and see how you do on it.
Okay.
Sound good? Good.
Maybe in the Google Classroom?
Yep, it'll be in Google Classroom.
He's gonna teach us how to swim by chunking us into the water.
Yeah, sounds great. I love it.
If you drown and drown, but you'll be back next week.
We'll be back next week.
That's right.
My favorite word is German. What? My favorite
Malcolm,
name is
just
German.
you're not funny today. You're trying too hard.
Try